Hi, explorers. Have you ever looked up at the sky on a beautiful day and wondered, why is the sky blue? After all, outer space is completely black. So why doesn't the sky appear white? Today, we're going to uncover one of the most fascinating secrets of our atmosphere. Get ready to travel from Earth all the way into the world of tiny invisible particles. Let's find out why our sky is blue. To understand why the sky is blue, we first need to understand sunlight. The sunlight that reaches Earth may look white to our eyes, but white light is actually made up of many different colors. Red, orange, yellow, blue, indigo, and violet. Together, these colors form what scientists call the visible spectrum. You can see these colors whenever sunlight passes through raindrops and creates a rainbow. Each color travels as a wave of electromagnetic energy. But here's the important part. Not all colors have the same wavelength. Red light has a long wavelength. Blue and violet light have much shorter wavelengths. And those tiny differences are the key to solving our mystery. Now let's look at Earth's atmosphere. Our planet is surrounded by a giant blanket of gases. This atmosphere extends hundreds of kilometers above Earth's surface. Most of it is made up of nitrogen and oxygen molecules. These molecules are incredibly tiny, far too small for us to see. As sunlight enters Earth's atmosphere, it doesn't simply travel straight to the ground. Instead, it collides with billions and billions of gas molecules. When light strikes these tiny particles, something amazing happens. The light gets scattered in many different directions. More than 150 years ago, British scientist Sir John William Strutt, better known as Lord Rayleigh, discovered something remarkable. He found that shorter wavelengths of light scatter much more easily than longer wavelengths. This process is now called Rayleigh scattering. Blue and violet light have short wavelengths. That means they bounce off atmospheric molecules much more frequently. Red and orange light have longer wavelengths. These colors travel through the atmosphere with much less scattering. In fact, blue light is scattered about 10 times more strongly than red light. Imagine throwing tiny ping pong balls and large beach balls into a crowded room. The smaller ping pong balls would bounce around much more. Blue light behaves in a similar way.
As sunlight enters the atmosphere, blue light gets scattered in every direction. No matter where you look in the daytime sky, some of that scattered blue light reaches your eyes. And that's why the entire sky appears blue.
Wait a minute. If shorter wavelengths scatter more, then violet light should scatter even more strongly than blue light. So why isn't the sky violet? Great question. There are actually two reasons. First, our eyes are much more sensitive to blue light than violet light. Human vision simply detects blue more efficiently. Second, some violet light is absorbed in the upper atmosphere by a layer of gas called ozone. Because less violet light reaches our eyes, and because our eyes respond better to blue, the sky appears blue instead of violet. Science can be surprising! Now let's solve our second mystery. Why do sunsets appear orange, red, and sometimes pink? When the sun is directly overhead during midday, sunlight travels through a relatively short distance in the atmosphere. But during sunrise and sunset, the sun sits low on the horizon. Its light must travel through much more atmosphere before reaching us. Along this long journey, most of the blue and violet light gets scattered away. Only the longer wavelengths, reds, oranges, and yellows, continue traveling toward your eyes. As a result, the sky near the horizon glows with warm colors. Dust, pollution, volcanic ash, and clouds can make sunsets even more dramatic by scattering additional light. That's why every sunset is unique. Imagine standing on the moon. The moon has almost no atmosphere. Without atmospheric molecules, sunlight cannot scatter. Even though the sun shines brightly, the lunar sky appears completely black. Astronauts on the moon experienced exactly this. The same thing happens in outer space. Without an atmosphere, there is no blue sky. This shows just how important Earth's atmosphere really is. So, why is the sky blue? Because sunlight contains many colors, and Earth's atmosphere scatters blue light more than the other colors. That scattered blue light reaches our eyes from every direction, making the sky appear blue. I'm Coco, your young science explorer. Thanks for joining today's adventure. And remember, every great discovery begins with a simple question.